Okay, so we're going to be doing some review questions for your quiz on financial mathematics, starting with number 1. In city Y, house prices have increased by 3% each year for the last 3 years. You'll notice that what's happening here is that we are increasing by 3% each year, and that means that our multiplier then, we're effectively multiplying by 1 plus our 3% increase. Just to say that we're going to be multiplying by 1.03 each year. So the house cost $180,000 3 years ago. What would be the dollar value to the nearest dollar today? So that means that 3 years have passed. So our original $180,000 value has grown by 3%. That's our 1 plus 3% for 3 years. Let's see what that gives us. 180,000 multiplied by 1.03, that's the growth by 3%, to the power of 3 to represent that 3 years have passed. And we get to the nearest dollar, 196,691. Alright, in City Z, a house worth $100,000 3 years ago is now valued at $119,102 American dollars. What is the yearly percent increase in the value of the house? Alright, so now our $100,000 house is being multiplied by some amount. I'm not sure what the percent increase is, so let's just make it 1 plus R, where R represents that yearly percent increase that we're trying to find. And 3 years later, so it's multiplied by that increase 3 times, we end up with 119,102. Now I could try to solve this algebraically, I suppose, but why bother when I have a calculator available to me? And so I'll say y equals, this is one method, I'll show you another method in a minute using the finance program. So 100,000 times 1 plus x to the power of 3, and my other function, my right hand side, is 119,102. Now you notice that this right hand function, 119,102, that is a constant value. So in my window, I need to make sure that I can see that value by increasing my y max to at least 119,000. Why don't I set mine to be at 125,000? That's safely above. I also know that my x is representing my rate of increase, so obviously my x min doesn't have to be negative, so I'll make it 0, and perhaps I should make my x max as high as 15 just in case it's a high rate of increase. And now I'll graph. And so going across the top, there's my function, my constant function. Now then, I have to think about why I'm not seeing anything right now. Oh, I see what I've done. This r, because I didn't write r over 100, then this r is representing a decimal value, isn't it? So I think I might have been better off back here to have made it r over 100, so that r would be expressed as a percentage. So let me go back into my y equals, and I'm going to change this 1 plus x to 1 plus x over 100, so that now x represents a percentage. So 100, close parentheses, now to the power of 3. Let's give that a try on the graph. Oh dear. Oh yes, I didn't get rid of this end of bracket, sorry. So let's delete that end of bracket. So I've got 1 plus x over 100. And what's this junk at the end that didn't delete properly? Gosh, what a mess. So let's delete, delete. Oh my gosh, I don't even know what it's doing right here. Can you just delete, for Christ's sake? Come on. Delete! Alright. When all else fails, let's just clear it and type it in again. Sorry, a bit frustrating. 100,000 times 1 plus x over 100. Close the parentheses, raise it to the power of 3. Graph. Alright, there's our gradually increasing function, and there is the constant value, and clearly where they intersect, that will represent the rate of increase. So I'll say second calc intersect, that's my first curve, that's my second curve, and as a guess, I'll move the cursor close and hit enter, and it looks like 6.000, so I think it's safe to show then that R is equal to 6.00% when I round to three significant figures. Just to show my work here, not only should I have my equation, but I should also draw a very quick sketch of what I've done. And so the sketch could look something like this, where I've got my constant function coming across. That was my y2 is 119,102. And I've got my growing function, which intersects right there. So my growing function is y1 equals 100,000, 1 plus r over 100, or x, maybe I should call it, to the power of 3. And then they intersect at 6.00119102. And so just show the graph, because that demonstrates the method that you have used. Another way we could have solved this problem is using the finance program. So I'll go into apps, finance, the TVM solver. So the number of time periods is 3. We're only compounding once a year, so I can leave these both as 1. My interest rate is what I'm trying to find. My present value of the house, so if I paid for the house, I had to pay 100,000, so that's negative 100,000. And my future value is positive, because that's the money going to be coming back to me, 119,102. And now I'll go up to the thing I'm solving for, which is the interest rate, and go alpha enter in order to solve, and there we go, there's the interest rate of 6.00%. Let's move on to number 2. The exchange rate from US dollars to French francs is 1 US dollar equals 7.5 French francs. So we expect to have more French francs than dollars by the time we're done. We're starting with $115. So I should take my 115 and I should multiply it by 7.5 French francs in order to end up with a larger amount. I'll show you another method to do this in a minute. If you're not sure whether you should multiply or divide, I'll show you a different method. Anyway, I end up with $862, or francs, sorry, 0.50. We must round to 2 decimal places when we're dealing with money. French francs. Another way you could have solved this problem would have been to set up some equal ratios. 115 US dollars is equivalent to how many French francs? Let's call it X French francs. Well, this ratio is going to be the same as 1 US dollar divided by 7.5 French francs. And once we set up a fraction equal to another fraction, we can cross multiply. So X times 1, which is just X, isn't it, is equal to 115 times 7.5. And that's exactly what I'd done up here, 115 times 7.5. So it took an extra step, but for some of you this is going to be worth the while so that you don't multiply or divide when you should have done the opposite. Part B, Roger receives 600 Australian dollars for 2,430 French francs. Alright, so why don't we figure out what the conversion rate is between Australian dollars and French francs, and then perhaps we can use that conversion rate for the rest of the question. So let's see, we've got okay, let me just think about how I want to approach this. Perhaps I should see how many American dollars there are in 2,430 francs. So X US dollars is equal to 2,430 French francs. And so let's set up the common, the same kind of ratio, 1 US dollar over 7.5 French francs. If I cross multiply then, I'll have X times 7.5 is equal to 2,430 times 1, which means that X is going to equal 2,430.1 divided by 7.5. So let's see how many US dollars we get for 2,430 francs, sorry. So 2,430.1, it's times 1, isn't it? Oops. Times 1. And then I'm dividing by 7.5. Okay, I get exactly 324 American dollars. So now 324 American dollars is equivalent to this many francs, thus is equivalent to that many dollars. So we got 324 US dollars equals 600 Australian dollars. And let's find out the value of the US dollar. So that's 1 US dollar. How many Australian dollars are we going to get for it? So again, we'll cross multiply. We get 324 times x is equal to 600 times 1. And so x is equal to 600 times 1. 600 divided by 324.